So this is chapter 2, lesson 6, the last lesson in this chapter. Theorems. Theorems we prove, right? Postulates are self-evident truths. Look on page 65. A mathematical theorem should answer a question or solve a problem that posed itself during a discussion. That's what theorems are. We prove theorems. A couple of the most famous theorems are in this lesson. The first one being the Pythagorean theorem. When can we use the Pythagorean theorem? Trez.
Finding the length of the hypotenuse.
Okay, we can find the hypotenuse, but when particular, what do we apply the Pythagorean theorem with?
Like construction where
Triangles.
What kind of triangles? Will? Right triangles. How many? It has to be a right triangle. Actually, if I did not have a right triangle, and I wanted to, let's say the triangle wasn't marked, and I were given the lengths of 3 sides, I could determine whether or not it's a right triangle, just given the lengths of the sides. All right, so Pythagorean's theorem says a squared plus b squared equals c squared, right? And it has to be applied to a right triangle. How many parts are there to a right triangle? There's actually 2. There's 2 legs, and there's the hypotenuse. 2 legs and the hypotenuse. The hypotenuse, everybody look, here's the right angle. The hypotenuse is opposite the right angle. It is always the longest side. It is always the value of C. All right. So if I had a right triangle and I told you that side length is 5, that is 12, could I find that length? Yes, I could. I would take my 2 legs, 5 squared plus 12 squared equals x squared. What's 5 squared? 25. What's 12 squared?
144.
144 equals x squared. What's 25 plus 144? 169 is x squared. How do I solve for x? I take the square root of both sides, and the value of x is 13. All right, let's look here. In algebra, when we take the square root of both sides, typically this is plus and minus. So let's remember that in algebra. It is not with the Pythagorean theorem. Why? Why is it not plus and minus, Nathaniel?
Because you can't have a negative length.
You're exactly right. It is also not positive and negative when I'm talking about time, because there's no negative time. Only in that one movie, Back to the Future. Right? That's the only place where there's negative time. That's theater, not real life. Okay? Theater is great. Now, what if instead of those sides that I had and the x was here? What's the formula? Say it, everybody. A squared.
Plus c squared.
Okay, yes, equals c squared. Plug in the numbers. Go.
X squared.
X squared plus
3 squared.
equals
5 squared.
All right, so x squared plus 9 equals
25.
25. I subtract 9 on both sides. I have x squared equals 16. I take the square root on both sides. X equals
4.
okay. Let's suppose I had an unmarked triangle. I really didn't know. But let's say the sides were that. Let's make them not, let's make, yeah, I'm just gonna leave it like that. And I asked you, is that a right triangle? Okay, let's prove it. It would have to be 6 squared plus 6 squared has to equal 6 squared. 6 squared is? 36. 30 equals 36. What's 36 plus 36? I cannot even keep this straight. 72, 72, and 36. So what is true? 72 is greater than 36, right? Anytime you have a squared plus b squared greater than c squared, you have an acute triangle. It's always acute because those other two sides are not long enough. That third side is not long enough to exceed the value of a squared plus b squared. Now, what if I had, I'm not going to draw the triangle, but what if I had, my sides were 3, 4, and 20. Okay, and I wanted to decide, can I have, is that triangle white? I have to make sure it makes a triangle. Here's something you'll learn later. The sum of any two sides has to be greater than the third in order for it to actually be a triangle and the endpoints meet, okay? All right, 3 squared plus 18 squared equals 20 squared. All right, you got your calculators? We know what 3 squared is. 3 squared is 9. We know what 20 squared is. What's 20 squared?
4,000.
Huh? 20 times 20.
400.
400. What's 18 squared? That one I don't know.
324.
What is it?
324.
324. What's 324 plus 9? 333. That is actually less than 400. When a squared plus b squared is less than 400, we have an obtuse triangle. So we have one very long side, another long one, and then a short one. It's obtuse. So actually, Pythagorean's theorem only is equal when it is a right triangle. However, if I had the lengths of 3 sides of a triangle, I can apply Pythagorean's theorem to tell me, is it an acute or is it an obtuse triangle? Okay? That is one famous theorem. Turn the page, 66. Another famous theorem is the triangle sum theorem. The triangle sum theorem says the sum of the angles in a triangle is 180 degrees. How do we know that? If we say that's 1, that's 2, that's 3. If I draw a line parallel to the base, so that line is parallel to the base, okay? Then there's something true about parallel lines and the angles that they form, which is in a future chapter. But, okay, let's just look at this. If this is an angle here, then that angle is the same angle. Okay? You see that? All right. So this angle here is equal to the same angle here, 3, because of the parallel lines. This being the transversal, okay? Ignoring this leg, right? Parallel lines, this, 3, 3, just like the AA. Do you see that? Okay, applying it on this side with the 2. Parallel line, 2 here, 2 there. What kind of angle is this? The whole thing. It's a, what is it, Trace?
180 degrees.
It's 180 degrees, and we call it a, Hannah? Straight angle. That's right. That's how we know that the sum of the angles in a triangle is 180 degrees. Here's the formula for the sum of the angles in any polygon. Did I already give you this formula? It's 180 times n minus 2. Yes, ma'am?
What is the first symbol?
What is the first one? Oh, sum. Sum. Means sum in math. The sum of the angles in any polygon is equal to 180 times n minus 2. So if it's a square, n being the number of sides, I should define what it means. N meaning the number of sides. And in any polygon, the number of sides equals the number of vertices, right? 3 sides in a triangle, 3 vertices, okay? So if I were to ask you, what if I have a polygon that has 8 sides? What's the sum of the angles on the inside? On the inside, they're called internal angles. It's 180 times n, which we're going to be 8 minus 2, which is 6. What's 180 times 6? 1080. Somebody confirm? Abby, is that what you got? Excellent. These are the internal angles, so 8-sided. 1, 2, 3, 4, 5, 6, 7, 8. 8-sided. If I add all of these angles up, the sum of them is going to be 1080. All right, look at the 2 circle theorems. One has to do with the diameter, and one has to do with the radius. The diameter of a circle is d, and its circumference. How many dimensions is circumference? 1, 2, or 3? 1. That's right. It's as though I took that circle, right, and I cut it and laid it out and measured it. That's circumference, okay? If the diameter of a circle is d, its circumference is pi d. So circumference equals pi times the diameter. In geometry, we leave pi as pi. We do not put 3.14 in there. You're at a higher level math, and exactness is preferred. The letter pi, the symbol for pi, is more exact than 3.14. All right, if I have the radius, all right, what is the diameter? The diameter, tell me the diameter. What is the diameter in a circle? And how many are there? Sarah?
It's the, describe it.
It's kind of hard to put words to it, huh?
It's just like a line across the middle. The distance from one side to the other.
That's exactly what it is. It's actually called a chord. It's a chord when you have lines that intersect the circle, the edge of the circle. That's called a chord. It's actually the longest chord. It's the longest chord in a circle. So it's a line segment that intercepts the edges of a circle and goes through the center. Diameter has to go through the center. There are chords that don't go through the center, that intercept the sides. A radius is more like a ray, and its beginning point is the center, and it intercepts the edge of a circle. So really, these are all radii, aren't they? But this is also a diameter. There are an infinite number of diameters and radii in a circle because I can draw them all the way around, right? There's an infinite number. So instead of circumference equaling pi d, I can say it's 2 pi r because 2 radii make a diameter. And we prove that. Do you know what the value of pi is? Well, you know it's 3.14. But isn't it interesting looking at this formula? If I solve for pi, what do I do? I divide by d on both sides. Pi is always, no matter the size of the circle, it's the circumference divided by the diameter. Isn't that amazing that our world, creation, is so orderly that no matter how small or how huge the circle is, the value of pi is always the circumference divided by the diameter. It is a constant. Okay, to me, just to contemplate that is amazing. To know that God could put into order creation such that this value never changes. The same is true with so many mathematical formulas. In physics, when we talk about gravity, do you know that the formula for gravity doesn't change? It doesn't change. It is always the same. I don't go to Alabama and suddenly I'm in a different place and I weigh more because gravity is different, or I start floating in the air because gravity is different, right? It's the same on the entire planet. The formula is constant. Why? Because we have an orderly God. So there are some famous